Hey everybody, this is Chapter 5, Section 1. Title is Rate of Change and Slope, starts on page 292. Chapter 5 is all about graphs, okay? What they look like, how to create them, what they mean. So we're going to head in that direction. A couple definitions to start with. A rate, the definition is a comparison of two things. So if I'm comparing two things, that's a rate. A rate of change is when you compare two things that are both changing. An example of that, speed is a rate of change. When you're driving along the road, your distance is changing and the amount of time is changing. They're both changing at the same time, so that would be a rate of change. You're comparing two things, how much the distance is changing and how much your time is changing. Speed then is a change in distance over a change in time, comparing both of those changes at the same time. And what you end up with there is a rate. A rate of change is constant if both things are always changing by the same amount. Okay, so here's how you figure out if a rate is constant. The table shows the distance traveled by a marching band over time. Is the rate of change constant? What does the rate of change represent? So we're going to look at this first set right here. Okay? So we know that distance is going to go on top, time is going to go on the bottom. So what I'm going to do is I'm going to subtract the two distances. So 520 minus 260. And that tells me how much the distance has changed, right? If I subtract, that tells me the difference or how much it's changed. So that's how much the distance has changed. And on the bottom, I put how much the time has changed. 2 minus 1. Simplify that, and I get 260 over 1. And I'm going to leave it as a rate. We talked about rates in one of the earlier chapters. We talked about rates and unit rates and things like that. Okay, so I compared the first two. Now I'm going to compare the next two. So again, I'm going to subtract the distance, 780 minus 520. That tells me how much the distance has changed. Now, how much has the time changed? 3 to 2. If I simplify that, I get 260 over 1 again. Okay, those match. And I'm going to do the last set from 3 to 4. How much has the distance changed? 1040 minus 780. How much has the time changed? 4 to 3. If I simplify that, again, I get 260 over 1. See, all three of these answers ended up exactly the same. If all of your answers are the same, that means that the rate of change is constant. What does the rate of change represent? Well, the 260, that's talking about feet, and the 1, that's talking about minutes. So the rate of change is talking about the number of feet that the band marched each minute. Because feet was my distance, minutes is my time, so it's the number of feet that they marched each minute. So this means that they marched 260 feet per minute. Okay. One of those for you, determine if the rate of change in the table is constant. Again, you should compare time 1 and time 2, time 2 and time 3, time 3 and time 4. Okay? If all three of your fractions, when you get them, are the same, that means that the rate of change is constant. If they are not all the same, that means that it's not constant. Reviewing a little bit from last chapter. Last chapter we sketched graphs comparing two things like temperature and time. We described what was happening to each variable on the graph. Like during the day, temperature went up, and then at nighttime, temperature went back down again. Things like that. We were talking about real-world problems with units and labels and things like that. In many math problems, you're not going to compare two things, but just two groups of numbers, things that don't have labels. In the real world, slope means how steep or flat something is. It's the same thing in math. You're trying to figure out how steep or how flat a graph would be. If something is steep, it goes up a lot, but not over very much. If you think about a steep mountain, for example. If something's flat, it goes over a lot, but not up very much. Okay? So if you look at two little lines here, this one would be steep. This one would be flat. Okay? The first one goes up a lot. The second one goes over a lot. Okay? That you should know the difference between steep and flat. Slope means that you're comparing how much up and down you go with how much side to side you go. You're comparing both of those things at the same time. Just like in the last chapter, we were describing what happened to both variables at the same time. Here we're just looking at the up and down part and the side to side part. There is an equation for slope. Slope really means, since we're talking about up and down, that means vertical. So slope is vertical change on top, and horizontal, which means side to side, on the bottom. One of the ways you might have heard this said before is slope is rise over run. Now, I always used to get rise and run confused. Which one means up and down and which one means side to side? Well, here's what I want you to think of. When you rise in the morning, when you rise out of bed, what you do is you stand up. So you're straight up and down. So rise means your up and down part. Run, when you run along the ground, you run in a sideways direction, okay? Try running up, okay? Try running all of a sudden and try to touch your ceiling. It doesn't work. When you run sideways across the floor, not up and down. Okay, so that's why rise means up and down, run means side to side. The rise part, the up and down part, always goes on top. So here's how we're going to use that. What is the slope of each line in parts A and B? Okay, it's a little hard to see, but there's a dot and there's a dot. So what I'm going to do is I'm going to count how far up and how far over I have to go in order to get from one dot to the other. So I'm going to start here, and I go up 2 boxes. So that means I went up 2. From that spot right there, I have to go over, and I go over 1, 2, 3, 4, 5 boxes. Up 2, and I went to the right, 5. Now, my up and down number always goes on top of slope. So 2 was my up and down number. 5 was my side to side number, so it goes in the bottom. So my slope is 2 over 5. If I look at the next one, there's one of my dots, there's one of my dots, okay? I always like to do my up and down numbers first, so if I start here, I go down 2 boxes, and I go 1, 2, 3, 4, 5, 6 boxes to the right. Okay, there's something a little bit different here. Up means positive. Down on a graph, if I look down, that's when the numbers go negative, right? So down actually means I'm going to use a negative number. So slope, again, it's the up and down number on top. And since it's down, that means -2 instead of +2. And then I went to the right 6. So 6 goes on the bottom. When you have slope, you want it to be a fraction, okay? If there's a whole number like 3, you want it to be a fraction, so you put 3 over 1. If there's a fraction you can simplify, make sure you simplify it. So this slope is -1/3, because I can take a 2 out of the top and a 2 out of the bottom. Okay. If you've got a graph, just count the number of boxes up or down that you have to go, count the number of boxes left or right that you have to go, and then put the correct one on top and the correct one on bottom. Simplify if you can. Here's a couple for you to try. As you have seen, you can figure out a slope from a graph. We just did that. You can also figure out a slope using a formula if they give you two ordered pairs. Here is the formula. Remember, slope is rise over run. And the equation for slope, which you'll need for every math class from now on, is y2 minus y1. Now think about y's for a second. Which way does the y-axis go? The y-axis goes up and down. Okay, so that's why this is the rise, because you're talking about what's happening in the up and down direction. Your x-axis goes side to side, so that's why those are on the bottom. So y2 minus y1, x2 minus x1. So when they give you two ordered pairs, the first one, an ordered pair is an x and a y. So the first ordered pair is x1 and y1. The second ordered pair is x2 and y2. Okay. Let's see how this would actually work. What is the slope of the line through these points? So here's my first point. So I'm going to label this x1, y1, and this one's going to be x2, y2. Okay. Once I figure out those labels, now all I have to do is plug it into the formula. So y2 gets written down first. y2 is -1 minus y1, which is 3. Now I move to the bottom. x2, which is a 4, minus x1, which is a 1. I put all four numbers in the correct space, and then I simplify. -1 minus 3 is -4. 4 minus 1 is 3. Leave it as an improper fraction. No mixed numbers when you're talking about slope. Can't use mixed numbers. Okay. Another one for you to try, same thing. Here's x1, here's y1, here's x2, y2. Plug those numbers into the formula and then simplify after that. You've seen that slopes can be positive and negative. Let's go back a second. Okay, when we did this one, this slope was positive. This one over here had a negative answer. What's the difference between the two? Well, the positive one, if you start on the left, it goes up and to the right. Whoops. If you look at this other one in letter B, if you start on the left, it goes down and to the right. Okay, that's the difference between positive and negative. There's also two other kinds of slope. If you have a horizontal line, that means the slope is 0. So if there's a straight horizontal line, slope equals 0. If you have a straight vertical line, straight up and down, we say that that slope is undefined. We're not going to talk a whole lot about what that undefined means right now. It comes up later in other math classes. But you do have to know that if it's a straight up and down line, it's not 0. The slope is what we call undefined. So you write the word undefined there. Okay? It's the only time when slope isn't a number. Every other case, your slope is a number. Okay? But if it's straight up and down line, then it's undefined. I have a little trick to help you remember those four different kinds of slopes. I call it my mountain climber. Okay? Imagine you're a mountain climber, and there's a mountain in front of you that looks like this. Now, the one rule is the mountain climber always starts on the left. So this is the left side of my line, so this is where my mountain climber starts. If I'm a mountain climber and there's this nice, big, tall mountain in front of me, I'm really, really happy. Happy is like having a positive attitude, so this means you have a positive slope. Okay, if you start on the left and there's a mountain in front of you, that means that you're happy and it's a positive slope. Now, over here, remember mountain climber always starts on the left. I'm a mountain climber, and the only thing that's in front of me is downhill. I don't like going downhill. I like to be at the top of the mountain. If I go downhill, maybe I have to, there's something down there I don't want to be a part of. I don't want to have to go home. I don't want to stop having fun. So if he has to go downhill, he's sad, and sad is negative, and that means that you'd have a negative slope if the mountain in front of you is going down instead of up. Okay? So that's positive and negative. We also have zero slope, right? If I'm a mountain climber, start on the left, and the only thing in front of me is flat ground, I'd be a really bored mountain climber because there's no mountain climbers, there's no mountains there. So this mountain climber, how much fun is he going to have? There's no mountain. How much fun is he going to have? There's no fun because there's no mountain. So since the fun would be zero, that means the slope is zero. That's just not a fun place to be if you're a mountain climber. Now, this last one's the best. If you have a straight up and down line, okay, that's a cliff. Okay? The mountain climber's standing here. Okay? He's standing on the edge of a cliff. If the mountain climber tries to go down that cliff without any rope or anything, what do you think's going to happen? Well, imagine there's like jagged rocks at the bottom. What happens to my mountain climber if he falls off the cliff? Death. Well, now all you have to do is remember that death means undefined. That mountain climber is undefined now. We can't even tell. He landed on the jagged rocks. We can't even tell that that was a person. Okay? He died. He's gone. He is now undefined. That one you just have to remember. Okay? The rest of the mountain climbers kind of make sense. That one you just have to remember. Hopefully that helps you remember positive and negative slope, which one's zero, which one's undefined. I've been using that for years, and it always seems to help my students, so hopefully it helps you too. It's the end of the lesson. Spot for questions and comments.